Math 20, this example comes out of lesson 5.2, which is about multiplying and dividing radicals. I'm taking one from your textbook that I get asked quite a bit, and it just says for you to rationalize and simplify this expression right here, negative 2/3 times the square root of 5 over 12u. Now do remember that you can write that, since neither of those two things reduce as they sit, you can also write that as negative 2 root 5 over 3 times the square root of 12u. Now that's not rationalized or reduced, but it does allow me to head to the next step, which I think, well, let's rationalize that denominator. To rationalize that denominator, I'm going to multiply by root 12u on the bottom, which means I'm also going to multiply by root 12u on the top. Now the bottom, great things happen. The square root's going to go away. I'm going to have 3 times 12u. On the top, I'm going to have negative 2 out front still, but the 5 times 12u can happen underneath the radical. So I no longer have a radical in the bottom, so I've done one part of my job, which was to rationalize the denominator. But what I have here still does reduce, does simplify more. First of all, if I look at 60, if I break down 60, and you can think all the way back to factor trees and breaking it down the old-fashioned way, are there any perfect square numbers in 60? And you'd realize, oh yeah, there's a couple 2's in there, so I can take a 2 out of the square root and give myself 2 root 15. So instead of having a root 60 over here, we could take out a 2 and leave a 15 under the root. So I've left everything else the same. The negative 2 out front, the u inside, the 36u on the bottom. But now I have negative 2 times 2, so negative 4 times square root of 15u over 36u. The only thing that can be done with that, again, it's already rationalized, the radical has been reduced, but 4 and 36 have a common factor of 4, so 36 divided by 4 is 9, and so this thing will reduce to be negative 1/9, or in other words, negative the square root 15u over 9u. And that's as far as that thing's gonna go. It's as reduced and simplified as you can get it.